In today's lesson, I'm going to do a few problems on absolute value functions and equations. So how to find the domain and range of absolute value functions, and then how to sketch it by hand. And then I will also show it using a graphic display calculator. And I'm also going to solve few equations involving absolute value. So let's get started with number one. Question number one is finding the domain and range of y is equal to -2 absolute value of x minus 4 plus 1. And we have to find the domain and range and sketch the graph. The first most important thing you need to know is the general form for absolute value function is y is equal to a absolute value of x minus h plus k. And h comma k is your vertex. Now, to find the value of domain and range, the first thing you need to do is whatever is in the absolute value, like here, x minus 4, substitute equal to 0. So x is equal to 4. And then, because h and k is your vertex, so which means 4 comma 1 is your vertex here. Once you know the vertex, you can sketch it. But if I want to find the domain and range before, so you can see from here, domain, x can take any values, positive, negative, 0, any value, which means domain is all x such that x belongs to R. So there is no restrictions on domain. And range in this case is going to be, so the value here, if x is equal to 4, then the maximum value you are going to get here is going to be for y is going to be 1, which means the range is all y where y is less than equal to 1. And again, this y belongs to real numbers. Now, if I want to sketch it, I can confirm this using the sketching here. So if I want to sketch this function, so first thing I need to do is when I find the vertex, I need to draw the vertex here. So let's say this is 1, 2, 3, 4, and then this is 1. So 4 comma 1, this is the vertex here. And after that, you will have the next step. I can draw a dotted line here. And then the next step is you need to find y-intercept in this case. So y-intercept means when x is equal to 0. When x is equal to 0, y is -2, absolute value of -4 plus 1. So this gives me -2 times 4 plus 1. So this is -8 plus 1, and which is equal to -7. So your y-intercept in this case is somewhere here. And then we just need to draw. And then it's going to be symmetrical, equidistant. So whatever is the distance between this. And remember, it's a sketch. So we don't have to be accurate. So this will be the graph of this absolute value function. So a, whatever is a, if a is less than 0, which means this opens down. If a is greater than 0, this is going to be open up. So to sketch the graph of this function, first step, you should find the vertex. After you have vertex, plot that point, make a dotted line, and then find the y-intercept. Once you have y-intercept, you will get a sense of the value, the first line, half of the graph, and then you can find the another half of the graph using the symmetry. It's a sketch, so you don't have to be accurate here. Okay, the next one is the sketch of find the domain and range of y is equal to absolute value of 2 minus 2x plus 1, and then you have to sketch the graph. Now, before you do any domain and range, first thing you need to do is change it into a general form, which is this. So which means I need to take here, because I need x first. So, and the coefficient of x in this case is -2. So what I'm going to do here is take -2 common. So x minus 2 plus 1. And now, if you have absolute value of a and b, it can be absolute value of a into absolute value of b, which means this will become -2. And then absolute value of x minus 2 plus 1. And absolute value of -2 is going to be 2. So 2 absolute value of x minus 2 plus 1. So we change this into this form. Now I know the vertex in this case is going to be, if I compare with the general form, the vertex is going to be 2 comma 1. So once we know the vertex, so here, and since in this case, your a is greater than 0, which means the graph is going to be opens up, and the vertex is going to be, in this case, minimum point. So this is 2, 1. And y coordinate determines the range of the function. So in this case, your domain is going to be all x such that x belongs to R. There's no restriction on domain. And range in this case is going to be y such that y is greater than equal to 1. So that is going to be your range here. In the previous one, since we had this vertex as the maximum point, that's why we had y is less than equal to 1. Now here, after you have domain and range, I'm going to sketch it. So when you sketch it, draw the vertex first. So this is 2 and 1. And after you have a vertex, draw a dotted lines, 2, 1. Find y-intercept. So y-intercept in this case is again x is 0. So y is equal to 2, absolute value of negative 2 plus 1. Absolute value of negative 2 is 2. So 4 plus 1, which is equal to 5. So then you have, this is 2. So 5 is somewhere here. And now we can draw. And now this and this has to be equidistant, roughly. You can do that. So that will be the sketch of y is equal to absolute value of 2 minus 2x plus 1, which we change into 2 absolute value of x minus 2 plus 1. Okay. So next question is, now we have to solve the equation consist of absolute value. So we will solve it exactly the way we solve the equation. So first step I'm going to do here is move this 2 on the right hand side. So we get negative 12 minus 2, 3x plus 6. So absolute value of 3x plus 6 is going to be negative 12 over negative 2, which is 6. Now, absolute value means whatever is in the inside can be positive and negative depending on what number you have on right hand side, which means 3x plus 6 can take value equal to 6. Or 3x plus 6 can take value equal to negative 6. Because if it's 6, absolute value of 6 will be 6. If this is negative 6, absolute value of negative 6 is going to be 6 again. So 3x is equal to 0, x is equal to 0. Here you will have negative 12 and x is equal to negative 4. So you got two values here. Now we need to check whether both the values satisfy this equation or not. So when x is equal to 0, I'm going to check. I will substitute in the given equation. So minus 2, 3 times 0 is 0, so 6 plus 2. So minus 2 into 6 plus 2, which is minus 12 plus 2 is minus 10. So x is equal to 0 is the solution here. Now similarly for x is equal to negative 4, negative 2, 3 times negative 4 is minus 12 plus 6 plus 2, negative 12 plus 6, and then negative 2. Absolute value of negative 6 plus 2. Absolute value of negative 6 is 6. So this gives me negative 12 plus 2, which is negative 10. So both the values of x satisfy this equation. Now the next one is absolute value of x plus 1 is equal to negative 2x minus 5. Again, now x plus 1 can be equal to negative 2x minus 5, or x plus 1 can be equal to, so x plus 1 can be positive or x plus 1 can be negative, right? So when we have x plus 1 as a positive, when you take the absolute value, you will get x plus 1. When x plus 1 is negative, when you take the absolute value, then this will become negative. Now here, if I solve this, this is going to be collecting like terms. So 3x is equal to negative 6 and x is equal to negative 2. Similarly here, negative x, negative 1 is equal to negative 2x minus 5. So negative x plus 2x is equal to, this is negative 4, this is x. So we got two values of x. Now we have to check whether both the values satisfy this equation or not. So for x is equal to negative 2 plus 1 is equal to, so I'm checking here, negative 2 into negative 2 minus 5. So this gives me negative 1. This gives me 4 minus 5. So negative 1 is equal to negative 1. So it seems like x is equal to negative 2 is a solution here. Now let's look at x is equal to negative 4. So negative, I'm going to check, substitute this in the given equation, negative 4 plus 1, negative 2, negative 4, negative 5. So this is negative 3, this is 8 minus 5, so this is 3. Sorry, this is negative 4, negative 5, yeah. So negative 2 times negative 4 is 8, minus 5 is 3, and this also is equal to 3. So x minus 1, okay. So x is equal to negative 4 and x is equal to negative 2. Let's check x is equal to negative 2 one more time. So when I substituted x is negative 2, I got negative 2 plus 1, which is negative 1. Oh, okay, I forgot to take the absolute value here. So when I take the absolute value, this becomes plus 1. So this is not a solution. Whereas here, okay, because of not writing it properly, so absolute value of negative 3 is 3. So this is the solution. X is equal to negative 2 is not a solution. So be careful. Okay, don't do the mistake which I did it. So it was not brackets, it was absolute value because you are substituting this in the given equation. Okay, you always need to check. So x is equal to 3 is a solution. Now if I want to check it graphically, let's see using the graph. So I'm going to enter y1 absolute value. To enter absolute value, I need to press on second 0 and then absolute value. And I have x plus 1. And now I'm going to enter y2, which is negative 2x minus 5. And if I graph it, so that's the graph of absolute value of x minus x plus 1. And then you can see there is only one point of intersection here. And to find this point of intersection, we can do second trace, which is calculate, and then go to intersect. Move your cursor closer to the point of intersection. Enter 3 times. Because first time enter, it's a guess on first curve. Enter second time, guess on second curve. And then you will get the intersection. So x is equal to negative 4 is the only solution here, as you can see from the graph. And we also find the intersection point here. Okay. The next one is we have to solve absolute value of 3x minus 4 is equal to absolute value of 2x plus 3. And we have to check the answer both numerically and graphically. So here, there are 2 different ways to do it. The first one is you can square both sides. So squaring both sides, you will get 3x minus 4 whole square is equal to 2x plus 3 whole square. Now open the bracket. This is 9x squared minus 24x plus 16. X squared plus 12x plus 9. Now simplify. 9x squared minus 24x plus 16 minus 4x squared minus 12x minus 9 is 0. So this is 5x squared minus 36x plus 7 is equal to 0. Now let's see if we can factorize it. So this is 5x and x, 1 and 7. That's going to work because 35 and x is 36. We need this to be negative and this to be positive, which means both has to be negative. So this, when we multiply negative 1 with negative 7, gives me positive 7. And when I add them, after cross multiplying, 5x times negative 7 is negative 35x. X times negative 1 is negative x. I will get negative 36x. So 5x minus 1, x minus 7 is 0. 5x minus 1 is 0. X minus 7 is 0. So x is equal to 1 over 5. X is equal to 7. Again, you must check. So for checking, you need to substitute this back into your given equation, or this for this example, I'm going to use GDC to check this one. So let's graph. So we have absolute value of 3x minus 4. So you go to second catalog and choose absolute value. And now you have 3x minus 4. So this is 3x minus 4. And then you have again second catalog, absolute value. And then you have 2x plus 3. So 2x plus 3. and graph. So when you graph it from graph, you should be able to see if there is 2 intersection point or 1 intersection point. Okay, it seems like we need to change the window setting. So I'm going to change the positive Y values, or you can use zoom standard, but I'm going to change the window setting here. So I'm going to make Y maximum maybe, let's say 20, and then graph. And then we can see if there is 2 point of intersection or not. So you can see the point of intersection. Now I can find them again. Go to second trace, go to intersect, and move your cursor. Find the intersection by pressing enter 3 times. So the first intersection you got is x is 0.2, which is x is 1/5. And then same thing, you need to have graph first, then go to second calc and intersect. And now this time we will find the second intersection here. Enter 3 times. And then you get intersection, which is x is equal to 7. So both of them satisfy the given equation. So this is how, and algebraically also you can substitute the value x is equal to 1/5 and see that whether that satisfies, and x is equal to 7 and this satisfied or not. Okay, now the another way of doing this, if you don't want to deal with squaring both sides, what else you can do is either 3x minus 4 must be equal to 2x plus 3, or negative 3x minus 4 must be equal to 2x plus 3. Now if I've simplified this one, then I get 3x minus 2x is x is equal to 7. And if I simplify this one, minus 3x plus 4 is equal to 2x plus 3, so I get minus 5x is equal to negative 1 and x is equal to 1/5. So you can also use this method or by squaring both sides, whatever works for you. Okay, that's it for this lesson.